Okay, we're continuing on with section 7.4. Now we're looking at tangents and secant, combination of those. So this list that I'm providing right here, I will provide on your test. Okay. Provided on exams. So no need to memorize this. You do need to remember the sine and cosine, but secant and secant tangent, cosecant cotangent works the same way. You're looking for the tangent being odd and the secant being even. If that's the case, if either of those cases or both are satisfied, then what you do, if you have a tangent, all what you have to do, follow the rules. Save secant tangent, and if you have secant, save a secant squared. That's your du again. Keep that in mind. So here, this has an odd. I'm supposed to save a secant tangent. I'm looking at example A. But I'm going to use 3, and 3 is right there. Tan squared plus 1 equals secant squared, and 1 plus cotan squared equals cosecant squared. So here, there is no secant to factor out. What I do, I say, all right, well, let's see. I could say that's the sine of x dx, and tangent squared is actually the secant squared minus 1. You know what I mean. When I say a sine, I mean a tangent. My mistake. Alright, so here we are. Now, if I let u equal, so this is actually the integral of secant squared of x tan of x minus tan of x dx. Need a bit more space. I have all the space in the world. So now if I take this first piece, if I let u equal tangent of x, I know du is the secant of x tangent of x dx. Secant squared of x dx. So this becomes the integral. There's my u. And secant squared of x dx is simply my du. And that integral right there is really straightforward, minus the integral of tangent of x dx. So this is u squared over 2, right? And I know that u was my tangent. And hopefully we have memorized that the integral of tangent is natural log of secant of x. Remember, the book might write this as negative natural log of cosine. Either way, we get our answer. That really doesn't matter. Either of those answers will be fine. And if I look at part B, so I'm going over all the combinations and the exceptions that you might come across. If I look at example B, I notice there's a secant squared, and it says if secant is even, save a factor of secant. So that's secant squared of x dx. That's my du. So this is following the rule. If this is my du, then I know if I take a derivative of tangent, I'll get. And then I'm glancing at this and thinking, well, okay, I know that tangent secant squared is tangent squared of x plus 1. So this is the integral of secant squared of x, or actually, let me put it in order. Okay, I'm out of sync today, I apologize. Tan squared of x, secant squared of x, plus secant squared of x dx. And here, it's fairly simple to see. If I let u equal the tangent of x, that's for the first piece, then du is secant squared of x dx. So this first integral is actually nothing more than a u squared, and secant squared dx is my du. That would take care of it. Plus the integral of secant squared of x dx. So that would be, add 1 to the power, that's u cubed divided by 3. And remember what u was. U was my tangent. And what do you take a derivative of to get secant squared? Derivative of tangent is secant squared, and there it is. Now if I move to the next set of problems, again I'm looking for even. If they're both odd, I know it's going to work, and if they're both even, I know it's going to work. But since it's hard to remember which is which, I'm providing this for you so you could use it. So here I'm looking at C, and I notice there's a cotan to the fifth and a cosecant cubed. So they're both odd. Well, it does match that rule. Tan and cotan go hand in hand, so I'm going to save a factor of cosecant cotangent. I'll save a factor of cosecant of x cotangent of x dx. That's going to be my du, which means I really need to go in there and see what's left. I took a secant out of that. That means cosecant. That means there's cosecant squared left. Oh boy. Cosecant squared of x left. And there is a cotangent to the fourth of x. Well, the deal is, if this is my du, I know I need everything to be in terms of cosecant, because the derivative of cosecant is cosecant cotangent. If this is my du, then this is fine. I really don't need to tamper with this. If I let u equal that, that will work. But cotangent I need to get rid of. So that's going to equal cotangent to the fourth is cotangent squared, right? And a cotangent squared in there. And I'm writing the extra steps so we wouldn't lose a track of what is what. So this I would always leave on the side. I wouldn't tamper with that. Now, I need to get rid of the cotangent, and I know from 3 that cotangent is cosecant squared of x minus 1. And if I really look at this, there's my du. Well, obviously I'm going to let u equal cosecant of x. The derivative of this will be negative cosecant of x, cotan of x dx. So below, before I lose track, there's my u, off by a constant. That's an easy fix. And there's my u. So if I really put that in there, that is the integral, and I need more space. We have plenty of space. That's going to be u squared minus 1 squared. That's another u squared. And that is a du with a minus. And let me color code those. There was my u, and my du was, there it is. And I know what this is. If I take u squared minus 1 squared, that is u to the fourth minus 2u squared plus 1. And if I distribute the u squared in there, I know that's the integral of u to the 6 minus 2u to the fourth plus u squared du. And now it's nothing more than a power function, and those I could deal with. That's negative u to the 7, but I know what u is. No need to add an extra step. It's right there. That's going to be cosecant to the 7 of x over 7 minus twice cosecant to the 5th of x over 5 plus cosecant cubed over 3 plus c. So keep in mind, I add 1 to the power, divide by that, add 1 to the power, divide by that, add 1 to the power, divide by that. So these problems are a bit long. You just have to be patient and work slowly at them. And if I look at this problem here, well, the same deal happens. I notice that they're both even. I know the rule works. Both even. That's really following the bottom. I'm going to save a factor of secant squared. So I need the secant squared out of that. There is a secant squared of 3x. And I know at the end, I'm going to divide, so I won't forget, I'm going to divide my final answer by 3. That will save me an extra u sub, because as it is, you see those are going to get longer and longer. You don't want to keep on adding a u sub for just a constant. Now if I take a secant squared, that means there's a secant squared of x left. That's this piece. And I know already what I'm going to do with tangent. I can't have a tangent in there. Well, tan squared is secant squared of x, 3x, minus 1. So that would be, let u equal, oh, I went the other way, didn't I? My mistake. Okay, well that happens. If this is my du and I'm not going to touch it, what do you take a derivative of to get? So that's a secant, okay, secant squared of 3x, and that's a tangent squared of 3x. Well, what do you take a derivative of to get secant? You take a derivative of tangent, which means I need to get rid of this piece. There's a tangent squared of 3x, and I know secant squared is tangent squared of 3x plus 1. And my secant squared of 3x, my du, I make sure that I don't tamper with that anymore, otherwise I'll run into a loop. Let u equal the traditional tangent of 3x. Du will be secant squared of 3x dx and times 3. So my du is right there. I'm off by a constant, so I'll take the 1/3 up front. Again, I'm gonna color code those just to make it simpler. There we go. This is off by a 3, no big deal. That is u squared times u squared plus 1, and there's my du. So that would be 1/3 the integral of u to the 4th plus u squared du. And the 1/3 came out by itself right there, by my u sub. So this would be add 1 to the power, divide by that. Again, no need to write u. I could actually say, you know what, that's u to the 5th over 5 plus u cubed over 3 plus c. So I could say that's 1/3, and wouldn't that be what's u? Tangent to the 5th of 3x over 5 plus tangent cubed of 3x plus c. So if u wouldn't have came out, if 1/3 wouldn't have came out, I would have divided by 3, and that would be my final answer. And I move on to my next problems. I notice there's a small problem. This is tangent squared of x, and there is no secant, and I need tangent to be to an odd power. I could go to sines and cosines, or if I remember that tangent squared is secant squared of x minus 1 by property 3, right there. I would know that. What do you take a derivative of to get tangent? The secant squared, derivative of tangent is secant squared x plus c. The deal with this problem, part C, if you remember this trick, it would be a lot more challenging than you think. If you go to sine and cosine, it will work, but it's going to be a long problem. Now, what if I look at a problem and it doesn't match? I want tangent to be odd and secant to be even. And I notice here they're backwards. Tangent is really even and secant is really odd. That means this rule doesn't apply. And if that doesn't apply, what I do, I go for my sines and cosines. Tangent is sine squared of x over cosine squared of x. And secant is really cosine cubed of x dx. So anytime I look at tangent and secant and it doesn't match that rule, I have to either go to sine and cosine or use some identities. Sine and cosine is an easier way out, I think. So that is the sine squared of x times cosine of x dx, and this brings us to what we learned in the previous half of this lesson. I know that if I let u equal tan sine, du will be cosine. That will work. And it's that simple. If I let u equal the sine of x, du will be the cosine of x dx. That will work. And that's all I need. So this is my integral of u squared du. And again, there's my u, there's my du. That would be u cubed over 3 plus c. Again, you could save yourself a step and say, wait a minute, I know what u is. Why not jump straight to this answer and say that is the sine cubed of x over 3 plus c. And that would be my final answer. And that would be the rest of this section. I could have covered the entire section one shot. The reason I broke it into two, these integrals are going to be coming up all over the place as we move on. You really need to digest them. And that would be it for this section.